I welcome you all to the Spark Research YouTube channel. This is Dr. Vichand, Assistant Professor in the Department of ECE. So this is the one another series where we are going to take the contents from this particular course, Signal Processing. And this is the second part of this unit, first and second and last part, where we are going to talk about the signals and system, right? Before going ahead, let me tell you we will get the contents in this series, like the for from the first 5 minutes, means all for 5 minutes, and we will also see the previous year questions paper which has already asked in the semester exam, and also we will take the some questions which has asked in the gate, different gate series sessions, right? So let's start the session. So here is the syllabus for your course, signal processing. So in this session we are going to take the contents from this classification of continuous and discrete time signals, where we will talk about the periodic, aperiodic, even, odd, energy, power, and deterministic and random. Also we will look into the types of the system, where we will see these type of the system, where linear, nonlinear, time invariant, variant, causal, non-causal, and static, dynamic, and stable, unstable system, right? So we are going to take both of the things. So let's start the session. So first, classification of the continuous and discrete time signal. So what is this continuous time signal and the discrete time signals? So continuous time signals means if your signal is continuous for all values of t. Suppose the x-axis representing the time axis and y-axis is your y of x of t, right? So y is equal to x of t, suppose. So for all values of t, you have the certain output, means for all values of x-axis we have the certain values of y-axis. So that is the continuous. But in discrete, like for not all values, you have the only particular values of the y for particular values of the time, that is the x, right? So here if you can see here, for t is equal to 0 you have certain output, that is y. For t is equal to, suppose this is 1 second, then at 1 second you have certain output, but in between that there is no y value, right, for these values of x. So means what? Means the signal is called the discretized on the time domain, right? So definition, the is your continuous time will define for all t, and discrete time will have the value at a specific time, right? Representation, you can see the continuous is a smooth and this is the sequence, right? And also the example, this is the processing in analog, and this discretized may be the digital, right? Example is your speech signal, ECG signals, these are the analog signals, and digital audio and the sampled the image, that are the example of the discretized. Okay, so let's take the another type of the system signals, that is your periodic and aperiodic. So periodic means, suppose if your signal is repeating after the certain time interval, that is called a periodic signal. Like see here, after this time interval, this is graph is the repeating the same type of the wave pattern. So this again, this is repeating, this one is also repeating, right? So all these are the example of the periodic signal. But if it is not repeating after any time interval, that is called the aperiodic. So periodic means repetition after the certain time interval, that is called the time period, and aperiodic, it will never repeat for any time, right? So repeat or not, so periodic will repeat, aperiodic will not, and definitely there will be the time period over which your signal is repeating. Example, the sinusoidal, square wave, all are the examples of the periodic. And exponential function, these are the sinc functions, so these are the example of aperiodic signal, right? So here is the some more examples. Sinusoidal function, here you can see sinusoidal function, this is the good example of the periodic signal. Why? Because your sinusoidal function is repeating with the time period of twice pi. So omega sine omega t plus twice pi will be equal to again the sine t only. So xt plus tau should be equal to x of t, right? If it is so, then this signal will called as a periodic, and the tau over which your signal is reporting, that is called the time period. For this is for the continuous. Similarly, for discrete, you can write x of n plus n is equal to x of n, right? So a signal is periodic if it does not repeat at regular interval. That is the aperiodic. As for example, your exponential function. Here you can see the output, that is y, is not repeating for any time interval. So these are the examples of aperiodic signals. Now we will talk about the even and odd. So whenever you are going to take the mirror image of your signal, and if it is same, right, means that is called the even signal. Means it should be symmetric along the y-axis on both mirror image. Here you can see this is the odd function. This is symmetric along the origin, right? Like this origin, not along the y-axis. So this is called the odd signals. Mathematically, x of t must be equal to x of minus t. So this is the mirror image. We have already seen the time reversal. You can, if you have doubts, you can check the previous lecture. I will drop the, your link in the description section. You can find. So that is the time reversal. So that is mirror image along the y-axis, right? So that is why this is called the even signal. And if xt is equal to minus of x minus t, in that case that will be called as a odd signal, right? So here it is the the symmetric along the origin. Clear? So some more details. So your mathematical condition x of minus t should be equal to xt for even, and x of minus t should be equal to minus of xt, that is your for odd. Example is your cosine function t square. These are even signals, and the sinusoidal and t to the power q, these are the odd signals. So here you can see your cos signals. This is symmetric along the y-axis, means whatever in the right side and left sides, both are mirror image to each other. So that is why this is even function. And here this is the the mirror image along the origin, so symmetric along the origin. So that is why this is the odd signal, right? And energy and power signal. Now let's find. So first of all, how to find the energy of any signal? So integrate over the minus infinity to infinity, and take the square, right? Xt magnitude square into the dt, right? So integration of xt magnitude square and dt from integration over minus infinity to infinity. This is the energy. And power is that you have to divide by the average, that is the 1 by twice of t, the time period, right? T is your time period. And if your energy, once you will calculate using this formula, if energy is finite, like 1 2 3 4 or any numbers, then this will called as a energy signal. And in this case, if you will calculate the power for energy signals, then it will be 0, right? And similarly for power signals, you can calculate the power, that is 1 by twice t, and integration from your particular time period only, minus t to xt square dt. Here we are taking average, right? So power is the average and energy is total, right? So 1 by twice t, and calculate it and check whether power is finite. If power is finite, that is called the power signal, and in that case energy will be infinite. So very simple. If power is finite, that is called power signal, and if energy is finite, that is called energy signal. And how to calculate energy and power for any xt? So energy you can calculate xt square and dt, and power, calculate that energy over the particular only time period and divide by that time period 1 by twice of t, that you will get the power, right, for that particular signal. Here I think we'll see the example here. So energy, for energy signal, energy is in between 0 to infinity and power is 0. And for power signal, your energy is infinity and power is finite, right? Example is your decaying exponential function is an example of your uh, energy signal. So you can calculate this. This will give the finite value of energy, and power is power is 0 because the time period is not there, right? And similarly, your signal, the sinusoidal or any cosinusoidal, all are the example of the power signal. Why is it so? Because time period is suppose 0 to twice pi for sinusoidal or cosine function, 0 to twice pi. If you will the absorb the power for this only one time period, then it will be finite, right? For only one time period, not and energy is for entire time period, so that is infinite, right? So in this case, if power is finite and energy is infinite. So now we will see the deterministic and a random signal. So deterministic is a signal is called deterministic if its behavior can be completely described by a mathematical equation and its future values can be precisely predicted. Means whenever you can have a particular equation, definitely that will be called as a deterministic. And random signal is called random if its future values cannot be exactly predicted and contain some degree of uncertainty. Means if we can define any the particular system or signals, that is the deterministic, and if we cannot define by mathematical equation, that is the random, right? So predictability for deterministic we can predict, for random we can't. Mathematical expression, that is we can write for deterministic only, and for random like we can have the probability only. Example is your sinusoidal, exponential, these are the examples of deterministic, and noise, speech, these are the types of the random signal, right? Okay, so we are moving ahead to talk about the system. So that's all about the signals. So in the system, a process or a device that takes one or more input signals, performs certain operation on them, and produces one or more output signals, right? So as for example, suppose transfer function t is the transfer function and xt is the input and yt will be the output. So transfer function of xt, so that is y of y of n, we can write t of x of n. So this is for discrete and this is for analog, that is continuous, right? So here input is your xt and output is your yt, and t is the some system, right? So the transfer function, so that will give you the certain output, right, depending on the values of the input. So that is called the system. So xt is your signal, yt is your signal, but yt is the giving the output based on this system. So t is a one transfer function for that particular system. As for example, your electronic circuits can take the some voltage as an input and give the certain output, right? So that circuit is a system again, right? Including your input signals. Audio filter, that is process some sound signals to remove the noise. So this is the another example of the system, right? Now let's take the types of the system. So first, linear and non-linear. So, and if your system is following the linearity properties, that is the additive, so that it will be the additive means superposition, additive and homogeneity scaling, right? So if a system follows the superimposition principle, na, this one, that means it is the linear. Otherwise, that system will be the example of the non-linear, right? So additive properties, the t of x1t and plus x2t is independently, if you will add this t of x1t and plus t of x22, that is y1t and y2t, both will be equal. And also a scaling property, that is t of ax of t is equal to a of t of xt. Now if you will add both, that is a scale the superimposition principle, that is t of a of x1t, so this will give the y1, and b of x2t, that is y2, and so again here this property will holds, right? So y1 and plus y2. So this, if this superimposition principle will holds, means if it is equal this and this, then it will called as a linear system. If both are not equal, means that in that case it will be non-linear, right? So we'll see the examples here. Suppose your function is your d square yt divided by dt square plus 3t yt is equal to t square xt, right? So here consider an input x1t which produces an output y1t, right? So y1, instead of the yt you can write y1t and write the equation, and similarly replace again x2t with the xt xt and write the same equations. Now check the your superimposition principle after combining equation 1 and 2, and check whether is it equal to this xat square and x1t and bt square x2t or not. So here if you'll see, then both are equal. Means what? If it is equal, means this is the example of the linear system, right? So linear means, actually this is the example, that is ramp function, means y is equal to x of t, simply txt. So this is the linear, and if it is a square now, particularly like x, so in that case your signal system will be the non-linear, right? Yt is equal to 5xt, so this is the linear, and yt is equal to xt whole square, that is the non-linear, because in this case your added superimposition principle will not be valid. Okay, so here now we are going to take another type of the system, that is time variant and invariant. So time variant means whenever you are shifting in the time, then output will remain same, that is the time variant, and if it is changing, that is called time invariant. So mathematically, when we are shifting in the input, that is x of t minus t naught by the t naught amount, then yt will be also shifted, that is y of t minus t naught, right? And the amplitude will remain same if you are shifting. But in certain case, in invariant case, in a variant case, if you are shifting by the t naught amount, in that case yt will be, the amplitude will changed. So that is the invariant variant, right? So system is time variant if behavior or characteristic change over time. This means that if you shift the signal input signal in time, the output does not simply shift by the same amount, it may be altered in the shape, amplitude or the frequency, right? The entire things will change, means the total equations will also change. But for time invariant, it will not change. So x, if you are shifting now, y dash t minus t, it will not be equal, right? So we'll see the example now. So example is here, yt is equal to 2t square into xt. Xt is your input and yt is your output. So here we are multiplying 2t square along with this input. So what is happening now, if you are shifting by amount t minus t naught or any amount, then what will happen? Yt will be the 2t square in x of t minus t naught, right? And since we are shifting, so in that case now t minus t naught will multiply here also. So because of this multiplication factor, this particularly only the x of t minus t the naught will not be equal to this, right? So y of t naught, whatever we are getting here, that will not be equal here. So since this equation and this both are different, so here yt naught and yt minus t naught both cannot be same, because amplitude is different. Here see, amplitude is 2t square at particular t naught, and here the amplitude is 2t minus t naught all square, right? So since amplitude is different, if we are shifting in the time, so what will be happen? This will not be equal, and that is why this is the example of time varying system. Here is the another example, the exponential function of 3xt. Now if you will shift the time by the certain time amount, then you will observe the same amplitude here, right? So there is no effect, so both are same. So this we are shifting, the we are t minus t naught, we are shifting, and then you are taking the the output at the delayed point, so both are same, so no problem. So this is the case of the time invariant system. Similarly, you can take the some more examples. I have considered only two examples, one from each, time variant and invariant, right? Now let's talk about the causal and non-causal system. So causal means whenever we have the, if your system is depends on either present or the past, means causal system, right? And if it is depending on the future, so that is called the non-causal system, right? So here future means t plus t naught, x of t plus t naught. So that is why it is in the left shift, right? So how we are writing t plus t naught or t minus t? Again, you can check the previous session where we have discussed about the time shifting, how to shift. So here in right shifting means t minus t naught. So this is causal system because this depends on the past. and this is the t plus t naught, so it depends on the future. So that is why this is the non-causal system, and this depends on the present. So causal system, this also depends on the present. Causal system, it depends on the past, because t minus t naught now. So that is why this is the also example of the causal system. So if your system depends on the past or the present, so that will be called as a causal. And if it depends on the future, like x of t plus 1 or t plus 2, these things, in that case this will be the example of the non-causal system. Some more example here, 2 of x of and y, this is definitely depending on the present only, so causal. Here this part 2 of x of n, that depends on the present, but 3 of x n plus 1, so depends on the future. So this, because of this part, the system entire will be the non-causal, right? Similarly, mathematical definitions you can see here. Now another y of t, f of xt minus t. So this depends on the past, this part depends on the future, and this part depend on the future. So overall the system will be the non-causal, right? Here you can take the some more examples. Yt is equal to x square t plus x of t minus 3. So this part depends on the present and this depends on the past, right? So you can replace yt minus 2 and check whether is it depends on the present or past. If it is not, then this will be the causal, right? So this is the example of the causal system. You can check it. Now let's move to the another type of the system, static and dynamic. So static is the memoryless, means it depends on the present only, and dynamic, static is the output depends only on the time, right, and not on the future. So these are not have the any memory. In dynamic system, it depends on the past as well, and it may have the memory as well, and can be modeled with the differential difference equation. So example is your RC type of the circuits or mass spring system. These are the examples of the dynamic system, and Ohm's law, that is V is equal to IR, is the example of the static type of the system, right? One of the BO, that is a bounded input bounded output type of the system here. So if your input is here, the bounded input you are giving, and output is also bounded, that means it is called as the example of the bounded input bounded output. If it is not, that is unstable system, right? So this is the unstable system. If a system does not satisfy the BO condition, the system is called the unstable, right? Here is the example, like yt is equal to exponential function for xt less than 6. So less than 6, that is why this is the BO, and it will have the fixed value. But if you will not put the limit, means in that case it will go for a longer values, and that case may be the unbounded. Okay, so that's all in this session. Thank you to join. If you have any doubts, you may drop your comments. In the next session we will talk about the, we will take the contents from the unit second. Okay, thank you.